Have you ever really thought about how the quiet little electrical signal inside your phone can turn into a sound big enough to fill a room? Well, today we're diving deep into the unseen world of electronics to talk about one of its most important components, the amplifier. We're going to see how it takes a tiny whisper and turns it into a massive roar.
Seriously, think about it. It's one of those bits of modern magic we just completely take for granted. The music stored on your phone is nothing more than a faint electrical pulse. So how in the world does that little whisper of a signal get powerful enough to fill your headphones, your living room, or even an entire stadium? Well, the answer is a device you probably use dozens of times every single day without even knowing it, the electronic amplifier. Its mission, if you will, is beautifully simple. Take a small, weak signal and create a powerful, almost perfect copy of it. You can almost think of it like an electronic photocopier, but with a volume knob that goes to 11. So how exactly does this little magic box work? To really get what an amplifier is doing, we first need to understand the tiny genius that lives right at its heart. And that little genius is the transistor. You know, it's really the unsung hero of all modern electronics. And when it comes to making sounds louder, it's absolutely the key to everything. More specifically, we're going to be looking at a type called the field effect transistor, or FET for short. Now I know, this chart looks a little intense, right? But don't worry about all the different names and details. The important thing is that all these different types of FETs, they all work based on one really simple, beautiful principle. And here's the best way to get it. Just think of a transistor as a super sensitive water valve. The weak input signal, you know, our music, that's like a tiny, effortless touch on the valve's handle. But that tiny, tiny touch controls a massive, powerful flow of water. And that's our amplified output signal. See? A small effort controls a huge result. That's amplification. Now, of course, engineers have a fancy name for this responsiveness of our valve. They call it transconductance, or just GM for short. But really all it is a measurement of how much more water you get for that tiny little turn of the handle. So a higher GM just means you have a more powerful, more responsive valve.
And here's what that looks like to an engineer. For them, transconductance is just the slope of this graph. See how it gets steeper? The steeper that line is at any given point, the more responsive our electronic valve is right there. A steeper slope simply means you get more amplification. But here's the catch. Take a closer look. That slope isn't a straight line, is it? It's steep in some places and kind of flat in others. And what that means is that the transistor's performance actually changes depending on how you're using it. And that little detail is the key to understanding why there are so many different types of amplifiers.
Okay, so if the transistor's performance isn't always the same, that means engineers have a choice to make, right? How exactly do they want to use it? This choice leads to all these different strategies for amplification, which we call amplifier classes.
You can think of these classes as different game plans. Each one chooses to operate on a different part of that performance curve we just saw. And, as you can imagine, that choice has some pretty big consequences for how the amplifier performs. So let's start with two of the most fundamental approaches. Over on the left, you've got a Class A amplifier. This one keeps the transistor on all the time, capturing every single piece of the sound wave. But on the right, you have a Class B amplifier. It's a bit more strategic. It only turns on for half of the signal, and then it basically takes a break for the other half. This table really lays it all out pretty clearly. Class A is kind of the perfectionist, right? It's always on to give you the highest possible sound quality, but it's a total power hog. Class B is much more efficient because it only works half the time. Then there's Class AB, which, as the name suggests, is a smart compromise between the two. And then you've got Class D, which is in a whole other league, using a clever digital trick to get amazing efficiency. So why bother with all these different classes? I mean, why not just use the best sounding one all the time? Well, it all comes down to one of the biggest challenges in all of engineering, the battle for efficiency. So what do we mean by amplifier efficiency? It's actually super simple. It's the ratio of how much useful power actually gets delivered to your speaker versus the total power the amplifier sucks out of your battery or the wall outlet. All the rest of that power, it's just wasted, almost always as heat. And this right here, this brings us to the very heart of the matter. It's the great trade-off in amplifier design. It's this constant battle between fidelity, a perfect, crystal clear copy of the sound, and efficiency, getting the most sound out for the least amount of power. And the tough truth is, you can't always have both.
This chart tells the whole story, loud and clear. Remember that amazing sounding Class A amplifier? Well, in a best case scenario, it wastes a staggering 75% of the power you give it as useless heat. Class B is way, way better. But then, look at Class D. With its digital wizardry, it can be over 90% efficient. That's a total game changer.
So why on earth is Class A so wasteful? Well, as this quote explains, it's because its transistor is always on, drawing power, just sitting there waiting for a signal to arrive. It's literally like keeping your foot on the gas pedal at a red light. You're just burning fuel for absolutely no reason. And that's exactly what a Class A amp is doing to your battery. Okay, this has all been pretty technical, so let's bring it back to the real world. Where do you actually find all these different amplifier classes in your own life? Well, that super high-end home stereo system, it's probably using a Class A or AB amplifier. When you're plugged into the wall, who really cares about efficiency? You just want the best possible sound. But your smartphone or that little Bluetooth speaker you take everywhere, they are all about that Class D life. They have to be, to squeeze every last drop out of the battery. It always comes down to what the device was designed to do. So the next time you turn up the volume on your phone or your stereo or your car radio, just stop and think for a second. What trade-off are you actually hearing? Are you listening to the result of a quest for perfect, flawless sound? Or are you hearing a victory in the battle for a longer-lasting battery? Now that you know the secret of the amplifier, you'll probably never listen to music in quite the same way again.